ladies and gentlemen, we're going to take a look at the beginning components of lesson 5.4A. This is our imaginary numbers, which is one of my most exciting parts of math, because this is where we actually just make math up. If we take a look at these equations that we were solving in 5.3, x squared equals 25, we know that when we take the square root, we get x is equal to 5 or negative 5. Because 5 times 5 is positive 25, and negative 5 times negative 5 is positive 25. Well, now what happens if we have to take the square root of a negative? What we find is there's no way to do it. There's no solution. If you actually calculate this on your calculator will tell you error. And so what we're going to do now is introduce these imaginary numbers. And these imaginary numbers are actually used when it comes to things like computer programming and solving some problems that help with creating the computers that we and the phones that we use today. What that is that if I need to take the square root of -1, it's going to be this imaginary number I. And if I take that same imaginary number I and square it, it's going to equal -1. So this is the only value squared that can equal a negative answer. And this is the only negative number we can take the square root of, -1, and it equals I. So we're going to go through and use that to help us here. Well, if we look at this, we have the square root of -49. And as I said, if you take this on your calculator is going to give you no solution. But if I break this into -1 times 49, now this -1 can come out of the radical because the square root of -1 is I. 49 now can break down into 7 times 7, and so this is going to come out. So we're going to call this 7i. This way I know it's imaginary. I know it came from a negative number. If we take a look at -40, we're going to start the same way. -1 times 40. -1 is going to come out as an I, so if you need to put the I there, you can. 40 is just 4 times 10. And then this is 2 times 2, 2 times 5. There's our pair. Those are going to stay under. So notice, guys, once I get rid of that -1, my radical operations, this simplifying the radical, looks the same. So now I have 2 times I on the outside that I've used for my square root, taken the square root of, and then 2 times 5 is 10. We're now going to look at adding, and it's the same way. I can only add like terms. I can only add imaginary numbers together. So 2 plus 9 is 11i. Now we're adding with radicals, so we're going to do the same thing. We want to try and get the same number into the radical, but we're going to have to simplify. We have 100 times 3, and this is 10 times 10. I'm going to stop here. I'm not going to let you guys take it any farther. So here's what's coming out. I've got 4 times 10 times I, and 3 stays under the radical. So I have 40i square roots of 3. I'm going to have to get an I out of this one, and it just so happens that I will, because I have -1. 75 is what I get when I break -75 into -1 times 75. I want to have a 3 left, so 25 times 3. And then 25 is 5 times 5. So this is what's coming out of this radical. There's a plus here, so 2 times 5 times I is 10i, and we have square roots of 3. Now we can add those together, and we have 50i square roots of 3. So because it's adding, we're simply going to split it in half and do each part, and then combine at the end for that adding. Subtracting is going to look the same. This is -1 times 16. This is coming out. This is 4 times 4, so it's this perfect squared out. So I'm going to have 4i. It looks like 64 is going to be the same thing. I'm going to have -1 times 64. Here's my I that's coming out, and then here's 8 times 8. So I have 8i. It's a minus, so 4i minus 8i is a -4i. Now we have to deal with some multiplication. So we're going to do 3 times 7 is 21, no different than what we did before. But then I times I is I squared. Now if we go back to the very first page, we gave you an important rule that if you have I squared, we need to turn that into a -1. So if we look at what this is actually going to be written as, this is going to be 21 times negative 1 for a negative 21. An imaginary times an imaginary actually makes an integer value. Let's take a look here. I cannot multiply them together first. What I have to do is simplify them. So negative 1 times 25, and then you have 5 times 5. So here's this perfect square of 5i, this perfect imaginary number, I guess we would say. Negative 1 times 4, and we have 2 times 2. So we're going to multiply that by 2i. Now this looks just like what we started with, so we're going to call this 10i squared. Remember, your I squared is a negative 1, so this is 10 times negative 1 for a negative 10. All right, we'll take some questions over these tomorrow. And last but not least, we take a look. It's still multiplication, but we're going to break things down. Negative 1 times 20. 20 is 4 times 5. This is 2 times 2. So this is going to be 2i with the square root of 5 left. This is going to be negative 1 times 18, 9 times 2, and this is 3 times 3. So these are all coming out. So I have times 3i and then square root of 2. Now I need to multiply this together. And so 2i times 3i is 6i squared. And then I can still multiply my radicals together now because they're both positive. So that's when the multiplication can happen. It has to be a positive radical, or I should write it this way. It has to be the radical of a positive times the radical of a positive in order to multiply them. So this is 10. Actually, this is 6i squared. I apologize, guys. I times I squared. So we have 6i squared times the square root of 10. Remember, this I squared is a negative, so it actually becomes negative 6 square roots of 10. All right? So we'll take a look at this tomorrow in class. Have a good evening.